All right, this is Mr. Baker, and we are going to go through Foerster's Algebra, test number 24, solutions. Question number 1. The question says that the diagram shows 4 lines labeled A, B, C, and D. Write the slope of each line and simplify as much as possible. We're going to go through just the first one, show you how to work out the slope of line A, and then assume that you would use the same principle for doing the slope of line B, and C and D are special cases which we'll talk about. So first of all, the slope of line A. Remember that the slope, abbreviated M, is the rise over the run. In other words, as you look at a line and you're moving from left to right, you're looking at how much that line rises, how much farther up it goes for whatever distance you're running from left to right. Also remember that if you have a line that's falling, if you look from left to right and it's descending, if it's coming down, well, that is written as a negative rise. So as we look at line A, you can see that it's going up as we travel from left to right, so it would end up with a positive slope. And line B, as you travel along line B, moving from left to right, it comes down or it descends. Well, that descending is a negative rise, and so we would expect line B to come up with a negative slope. So again, the rise, that's the vertical climb from left to right, and the run, that's the horizontal distance moving from left to right for that given rise. Well, one of the ways I like to solve these problems is to look on your line and find a place where the line goes through the intersection of 2 of your grid lines. I've shown the first one here with one arrow, and we'll look at another one, and those appear to be 2 places where the line travels through the grid lines. So what I'd like you to think about is, let's kind of make a triangle. Let's connect the distance it rises and the distance it runs, and it forms a little triangle. So as we consider, first of all, the rise, given the distance we've run, whatever it is, how much rise have we seen? And we don't know what the units are here. They could be in feet, in miles, in kilometers, in millimeters. We don't know. But for whatever it is, because this is a one-to-one grid system, we can see right here that the rise, for whatever units they are, has been 2. It's risen 2. And for every 2 that it rises, or for in the distance it's traveled, it's risen 2. And how far has it run in order to rise to? It's run for 7. If you look at the left arrow and count the number of blocks from left to right, there are 7 blocks in that line. And then as you look from that horizontal line vertically up to the other arrow, there's a 2-block rise. And so the slope for this line is equal to 2/7. That's positive 2/7. Now, if you look at line B, and we're not going to do all the different operations there, but if you look at line B, you'll notice that if you find an intersection of the line with the grid system and you move along the line, you're going to find another intersection for every 3 blocks that you travel down. And since we're traveling down, we know that that's a negative rise. Well, the negative 3, as we travel down 3 blocks, we move to the right 1 block. And so the slope of line B is negative 3/1, or just simply negative 3. The third line, C, is a vertical line. It travels straight up and down. And we learned that a vertical line, by definition, has no slope. If you do the math and as you approximate, as you get closer and closer, the math kind of blows up. And actually, the slope is actually equal to infinity, because you get an infinitely large rise over an infinitely small run. But for our purpose, we're just going to say that a vertical line has no slope. And then lastly, line D. Line D is a horizontal line, and you can see it on this grid at y equals 2. But it's left to right. It's a horizontal line. And horizontal lines, by definition, have a slope of 0. They're not rising, they're not falling, they're moving perfectly level. They have a slope of 0. Question 2. It says write the coordinates of points E and F. So we'll go back to our diagram from before and locate points E and F. Well, before we do that, I've drawn on here the origin, or the coordinate lines. This is our x line, our abscissa, moving from left to right. And we also have the ordinate, or the vertical, y. This is where x is equal to 0 and where y is equal to 0. And sometimes when you have a grid with all these different lines on, it's helpful to locate the origin. Where do the zeros cross at? And then remember, we're always counting in order to place our positions, our coordinates, relative to that 0 mark, where those two, on this diagram, where the two red lines cross. We're going to first of all look at point E and figure out where is point E located. What is the coordinates of point E? Now, if we start at the origin and we move in the x direction to where E is located, you see that you're moving to the left 4 places. And moving to the left from the origin along the x means we're going to the -4 position. And then moving from y is equal to 0 to wherever E is at, we move down 2 positions. And so from the origin, we can count left 4, down 2, and that gives us a position of -4, -2. We also would consider point F. And again, we're not going to do all the process here, but hopefully you can see that if you start at the origin and you move to the right, that point F is at approximately 2.8. And I kind of estimate to the 10th place. So it's approximately 2.8. And then vertically, going from y is equal to 0, moving up, you're going to move up 1, and then it looks like a little bit less than half. So that'd be 0.4. So its position of point F is 2.8, 1.4. Question number 3. For the expression 7x minus 5y, evaluate if x is equal to 10 and y is equal to 4. Well, what we're going to do in this case is simply take our expression, 7x minus 5y, and then we're going to evaluate it. We're going to do the math if we plug in those values for x and y. So our expression becomes 7 times 10, which was our value of x, minus 5 times 4, the value of y, and we do the math. That's 70 minus 20, or 50. So 7x minus 5y equals 50 when x is equal to 10 and y is equal to 4. Then they ask us to find x if the expression is equal to 81 and y is equal to 2. So we write the expression again, and this time we were told to solve it for, or to evaluate it with the expression being equal to 81. So we plug that in, and then further use the value of y is equal to 2. So we're going to replace every occurrence of the variable y with the number 2. Well, actually, the way I've done this, first of all, I'm going to rearrange the formula. I kind of like to do that and get it in kind of we're solving for x, and so I'm going to solve this equation for x. I have to do the same operation on both sides, trying to get x alone on the left-hand side of the equal sign. So I'm going to add 5y to both sides, and the expression now becomes 7x equals 5y plus 81. And then to get x alone, I'm going to divide that side by 7. I need to do the same thing to the right-hand side of the expression, and that leaves me with x is equal to 5y, but the value of y is 2, so 5y becomes 10, plus 81 quantity divided by 7. That's equal to 91/7, so x is equal to 13. So the expression 7x minus 5y is equal to 81 evaluated when y is equal to 2 equals 13. X equals 13. Third part, find y if the expression is equal to 3,000 and x is equal to 400. So again, we have the expression 7x minus 5y, and we're told that it's equal to 3,000. I'm going to go ahead and solve for y this time. So I need to get y alone on the left-hand side of the equal sign. So I'll subtract 7x from both sides. That'll leave me with negative 5y is equal to negative 7x plus 3,000. Now I need to divide both sides by the coefficient in front of my y. Divide both sides by negative 5. And that'll give me expression for y, which is equal to negative 7 times x plus 3,000 quantity divided by negative 5. So negative 7 times x, and in this case, x, we are told that x is to be equal to 400, so we plug that in, and we do the math. And the resulting of the math is y is equal to negative 40. So if 7x minus 5y is equal to 3,000, and x is equal to 400, then y is equal to negative 40. Question 4 says, tell the meaning of abscissa. If you remember, abscissa is the x-coordinate. That is the line in this graph right here, shown as the darker line going right through the center. The abscissa is the x-coordinate. You're moving left to right, the horizontal line. The ordinate? Well, the ordinate is the y-axis. The ordinate is the position relative moving up and down along that y-axis. So the x-coordinate and the y-coordinate are what the abscissa and the ordinate are. And then lastly, the fourth quadrant. What's the fourth quadrant? If you look at the graph on this slide, you'll see that the y is equal to 0 and x is equal to 0 lines, they form a perfect cross right through the center of the graph paper. And if you look at each one of the different quadrants, those are the different quarters relative to the origin, you'll see 4 of them right there. And we number them starting at the upper right, and we go counterclockwise 1 through 4. And they're indicated by their Roman numerals. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So quadrant 4 is that lower right-hand quadrant. The values of the positions, or the coordinates in the fourth quadrant, are x are going to be a positive value because they're the right of x is equal to 0, but y's are all going to be negative numbers because the y's are below y is equal to 0. So where is the fourth quadrant? It's the lower right quarter relative to the origin. Question number 5. Write the definition of the x-intercept. The x-intercept is the value of x when y is equal to 0. Now, let's go ahead and look at an example. Let's say that I had a line that we were assessing right here. And as we look at this line, there are a couple of key points that will help us in the future. We're going to use these numbers quite a bit. Those two places are, first of all, the y-intercept. The y-intercept is where the line crosses the y-axis. And it crosses the y-axis where x is equal to 0. The second point is over to the right of it on this line. This is the x-intercept. The x-intercept is that point where the line crosses the x coordinate, or the abscissa, and the value of y is equal to 0. So the y-intercept is when x is 0, the x-intercept is when y is 0. Number 6, plot the points 210 and negative 3, 2, and connect them with a straight line, and then write the x and y intercepts on the line correct to the nearest tenth of a unit. Now, one of the things you're going to find with this PowerPoint presentation is that I can only be so precise. It's difficult because you can't actually place these images exactly where you'd like them. So there'll be a little bit of error, but I'm just trying to give you a general idea of how to do it. On your own graph paper with a sharp pencil and a nice straight edge, you should be able to do these within a 0.1 or 1/10 of a unit. First of all, let's plot the point 210. First thing I'd like you to do is start at the origin. That's where these two blue arrows are pointing right now. And the first point is going to be at x is equal to 2. So we're going to move from the origin and move to the right, 2. And then the y position is 10. So we're going to move up from 0 to 10 and right 2 to give us a position of 2, 10. And we're going to place a dot right there. So where that dot is at now, it is 10 places above the origin and 2 places to the right of the origin. So x is positive 2, y is positive 10. The second point we're told to plot is negative 3, 2. X is equal to negative 3, which means from the origin we're going to move to the left, or negative, 3 places. And then from that point we're going to move positive 2, or up 2. And so the place where these 2 points intersect is the point negative 3, 2. Now we connect those two with a line, and that line goes on to infinity from in both directions. We're just seeing a segment of that line depicted here on our graph paper. It says now write the x and y intercepts on the line correct to the nearest tenth of a unit. Now where are the x and the y intercepts? Well, the y-intercept, remember, is where the line crosses, where x is equal to 0. Where does it cross the y? I mean, what is the value of y when x is equal to 0? And the x-intercept, that's going to be what is the value of x when y is equal to 0. In this case, we see the line crosses through where x is equal to negative 4.3 and y is equal to 0. And for the y-intercept, x is equal to 0 and the y value is positive 6.8. So if we had a formula for this line, and it was they had the variables x and y were equal to a constant, some multiples of x and some multiples of y were equal to a constant, we could determine the x-intercept and the y-intercept by putting, first of all, x in as 0 and solving for y, or put y in as 0 and solve for x. And mathematically, we would come up with the numbers that are represented here. Now, graphically, all we need are 2 points to define a line, or 1 point and a slope. And with either of those two cases, we can draw a line, and then graphically or mathematically solve for the values when x is equal to 0 and when y is equal to 0. Question number 7. It says for the equation 2x plus 5y is equal to 15, transform it to slope-intercept form. First of all, remember what the slope-intercept form is. Slope-intercept form is in the form y is equal to mx plus b. We're trying to take whatever actual equation we have and put it in this format. Remember that x and y are our variables, m is our slope, and b is our y-intercept. So when x is 0, that's the value of y. In this form, it's represented by the letter b, or the variable b. So the formula we're given is 2x plus 5y is equal to 15. Now we need to rearrange that formula to put it in the form y equals mx plus b. So we need to get y all by itself on the left hand of the equal sign. Well, first thing we need to do is subtract 2x from both sides, and that gives us 5y is equal to negative 2x plus 15. Now to get y alone, we need to get rid of the coefficient, so we need to divide both sides of the equal sign by 5. So 5y divided by 5 is equal to all of the right side, negative 2x plus 15, the quantity divided by 5. Now you can also write that as y is equal to negative 2x divided by 5 plus 15 divided by 5. You see, we can go ahead and take that 5 divided by 5 and distribute it across. And what this will do then is, as we simplify it, you'll see that y is equal to negative 2/5 x plus 3. So we've taken our equation, 2x plus 5y equals 15, and written it in a way that y is equal to something times x plus b, or y is equal to negative 2/5 x plus 3. Then it asks us to write the slope and the y-intercept. Well, we already have it in the appropriate format, and so we can see from this that y equals mx plus b. Well, if y is equal to negative 2x plus 3 and y is equal to mx plus b, just by looking at its form, you can see that the m value is negative 2/5 and the b value is equal to 3. Now it says plot, showing clearly how to use the slope. What we're going to do is take a graph paper and plot, first of all, our b. b is our y-intercept, and in this case, b is equal to 3. We'll put a dot right there on x is equal to 0, y is equal to positive 3. That's my point. And as I said before, you can draw a line in a couple different ways. One of those ways is having 2 points and then just simply drawing a line, straight line between them, going off in both directions. Or you can have 1 point and know the slope of the line coming out of that point. This method is going to use a point slope method for drawing the line. All right, so we have b is equal to 3. And the second thing we know is that the slope is at -2, 5. What is that telling me? That's telling me that, first of all, as I leave this point, I am going to rise a -2. Rising a -2 is the same as falling 2. So my next point is going to be somewhere along the line, the horizontal line, 2 grid lines below my point. That's the -2. My slope is a -2 rise, which is a 2 descent. And for every 2 that I descend, I run +5. See? M equals -2 divided by 5. M equals the negative rise over the run. -2 for every +5. And so now basically I've got a second point, down 2 and right 5, and if I were to connect those 2 points, it would end up with a line that looks something like this. This is my line of y equals mx plus b, or y is equal to -2/5 x plus 3. I had the point for my b, which is my y-intercept, and then using my slope, I computed the second point, and I connected them to form the line. Now it says in question 7d to substitute 4 for x and find y, and show that this point is on the line. So we go back to our formula. We've got y equals -2/5 x plus 3, and we're going to substitute 4 for the value of x, and the specific solution for this formula, when x is equal to 4, y is equal to 1.4. So when x is 4, the formula says we should have a y value of 1.4. Let's look over on our line and find where x is equal to 4. Well, x is equal to 4 at this point right here. So along this vertical line, we're going to cross our line at a place where the value is, at least in the x direction, it's equal to 4. So what is the value of the line where it crosses x is equal to 4? Well, if you look at our line, you can see that it's just a little bit below, halfway between 1 and 2. A little bit below halfway. Halfway would be 1.5. And so we can estimate from our line that it's approximately 1.4, showing that we can solve it graphically, and we've also solved it using the equation. Question number 8. Valentine sells large boxes of candy for $3 each and small boxes for $2 each. Let x equal the number of large boxes she sells and y equal the small boxes. Write an expression for the number of dollars Val gets for selling candy. Well, how much money she gets is going to be some combination of the dollars she makes for larges and the dollars she makes for smalls that she sells. And that expression is going to equal this. See, for every large box, and the large box is represented by the value of x, she gets $3. So $3 for every x is 3x. And $2 for every y is 2y. And the amount of money she makes is the amount she makes from selling the larges plus the amount she makes from selling the smalls. And so the total money she makes is 3x plus 2y. Now, if she sells 17 large and 23 small boxes, how much does she get? All we do is take our equation and substitute in the values we've been given. So x is equal to the number of large boxes. In this case, she sold 17. And y is the small boxes, and she sold 23 of those. We just solved the equation. So she sold $97 worth of candy. If she sells 17 large and 23 small, she will receive $97. Well, she decides to sell a total of $36. That's what her goal is for the day. She's going to sell 36 and then stop. Write an expression stating this fact. So the total she sells is equal to 3x plus 2y. If she wants to sell a total of $36, then 3x plus 2y is equal to 36. that's the expression stating that whatever she sells, she's going to stop at 36. So find the x and the y intercepts for the equation and plot its graph. Well, we know we're going to be plotting. We can find x and y. I'm just going to go ahead and take our formula, and I'm going to rearrange it to put it in the y equals mx plus b format. So I took my 3x plus 2y equals 36. I subtract 3x from both sides, and it becomes 2y equals negative 3x plus 36. Now I'm trying to get y all by itself, so I divide both sides by 2, and y is equal to negative 3 halves x plus 18. This is my slope-intercept format for my line. Now looking at this, I know that my y-intercept is going to be 18. How do I know that? Looking at y equals negative 3 halves x plus 18, it's in the form y equals mx plus b. In that form, my b is 18. And so 18 is my y-intercept. Now, if I take that expression and I make y equal to 0, remember, the value is going to be 18 when x is equal to 0. Now I want to solve for when y is equal to 0. So I take my y equals mx plus b, in this case y equals negative 3 halves x plus 18, and if I say, okay, the y is going to be 0, that means 0 equals negative 3 halves x plus 18, I need to solve for x now. And when I solve for x, x is equal to 12. So when y is 0, x is 12, and when x is 0, y is 18. Once again, I know that my value when x is 0, y is going to be 18 because that's my b when I write the equation in the format y equals mx plus b. And I know that x is equal to 12 when y is 0 because I took the equation, plugged in 0 for y, and solved it for x, and my result was 12. So I need to find the x and y intercepts, which I've done, and plot its graph. So we'll take the grid line right here, and I'm using a 10 by 10, or actually 20 by 20, but it's 10 in each direction from the origin. So I'm actually going to have to remember in my case that every one of these is actually worth 2, because I can't fit 18 since my numbers only go up to 20. So again, that's another reason why your graph will probably be a little more exact. I'll need to remember as I do this that every one is actually represents 2. So we need to plot the graph. I'm going to go ahead and where x is equal to 0, I've already said y is equal to 18. And where y is equal to 0, x is equal to 12. Those show up as 9 and 6 on mine because I'm using each grid is equal to 2. Then I just take those 2 points and I draw a line between them and connect them. And I've now plotted the solutions. I've plotted every solution, as a matter of fact, that is within the scale of my grid for this equation, for y is equal to negative 3 halves x plus 18. This graph right here shows me every solution, which means for every case where this person wants to sell, in this case Val wants to sell $36 worth of candy, every combination that will do that is on this line. As a matter of fact, it's more on here than is possible. You see, there's an infinite number of answers for this solution. There's an infinite number of ways that she can sell $36 if she were willing and able to take each box of candy and cut it up into smaller and smaller and smaller and smaller portions. But we know that's not the way real life works, which is why question E says Val can only sell whole boxes, meaning she can't break any boxes up. So every answer that we have is going to have x and y equal to a whole number, an integer number. There's not going to be any fractions or any decimals. They're going to be whole numbers. So since she can only sell whole boxes, write all the possible numbers of boxes that she could sell to make exactly $36. And frankly, you could do this mathematically and you can do it graphically. Hopefully on your paper, your scale is large enough that you can look at your line and you can start tracking that line and look at places where that line goes exactly through the intersections of your grid lines. Because at every point where that line crosses through an intersection of your grid lines, that is a point where you have a perfect whole number of x's and a perfect whole number of y's, and they solve the equation for the value being 36, or the expression equaling 36. You can also do it mathematically, and I'll go ahead and show you the different combinations. So our solution set for all the possible sales that she could make to get $36, she could sell no large boxes and only sell 18 small boxes. See, if she sells 18 small boxes, she makes $36 only on small boxes. And that's what's represented by our y-intercept, where x is equal to 0, she sold no large boxes, and y is equal to 18. She sold 18 small boxes. On the other extreme, all the way on the right, if she sold no small boxes and she only sold large boxes, well, then she'd only have to sell 12 because they're getting $3 a piece instead of 2. And she would still have $36 total in sales. And you're going to see as you look at your graph or as you solve the problem, they're going to walk up where the number of large boxes need to increase by 2. And since they each sell for $3, that would be a $6 difference. So we need to take the right-hand side down by $6. They're each valued at 2, so they need to decrease by 3. And we see that reading from left to right. As if she sells 2 larges, she only has to sell 15 smalls. If she sells 4 larges, she only has to sell 12 smalls. If she sells 6 larges, then 9 smalls. 8 larges, just 6 smalls. 10 larges, and she only needs to sell 3 smalls. And finally, as we already said, 12 larges, and she doesn't have to sell any smalls. And so by solving the math, by plugging it into the equation, or by looking at your graph and seeing where that line crosses through the intersections where x and y are equal to whole numbers, and just simply reading it and writing down the different points, your x and y values will solve this question: how many of each type does she need to sell exactly $36 worth? I hope that helps. If you have any questions, I look forward to answering them as we get together next time in class.